Focus, please. Joseph, wake up. Okay, it says solve the system by substitution method, not by graphing and not by elimination, right? Okay? And the reason being is that I wanted to make sure that you're practicing all the methods. Specifically substitution, since a lot of you don't like using substitution. I don't know why. All right. So let me go over this one really quick. It says solve the system by substitution method. So the first things first. For substitution method, make a little note in case you forgot. One equation, one EQ. Oh, it's frozen. Let it go. Okay. Needs to be solved for one variable. That's what's imperative. Important. Okay. That is imperative. And for you to be expeditious about your work, so look at it. Which equation would you like to solve for one variable? Which is the easiest one? Which one do you think is the easiest one? Tell your neighbor which equation would you like to solve.
Second one.
All right, I'm going to solve the first one since a lot of you are like, the first one. All right. So I'm going to rewrite this. 2x minus 2y equals 8. So which variable would you like to solve for? Emerald, x or y? Y. So that means we need to leave x by itself. So what do? Subtract 2x, subtract 2x. We're left with negative 2y equals negative 2x minus 8. And what is our last step? Divide by negative 2, divide by negative 2. Y equals, what is negative 2 divided by negative 2? 1x. And what is negative 8 divided by negative 2? Positive 4. Okay. Oh, it's positive 8. My bad. So this is negative 4. Yeah. Say it again. We're not eliminating. We're not. We're bringing the x to the other side. We're getting rid of the x from this side and bringing it to the other side. So let's look at the key steps. Do we have one equation solved for one variable? Yes, right here. The first equation is solved for y. Is that correct? So question, what is y? Y is equal to what? X minus 4. So on the second equation, instead of writing y, what do we write underneath there? In parentheses. X minus 4. That is correct, because that's what y is. Okay? So now let's bring everything else down. The negative 2x, the negative, the equal, and the 1. So let's solve that. Line down the equal sign. Question, what is a factor outside the parenthesis? Negative 1, so we're going to distribute that in here, so we get negative 1x and positive 4. Bring down the negative 2x, the equal, and the 1. Can I combine like terms? Yes. What is negative 2 and negative 1? Negative 3x plus 4 equals 1. What do I do from there? Minus 4 minus 4. Negative 3x equals negative 3. Divide by negative 3. Therefore, x equals positive 1. Are we done? No. Now we're going to substitute into the other one. So here, instead of x, what do I write underneath? A 1. Bring down the y, the equal, the negative 4. Y equals, what is 1 minus 4? Negative 3. Therefore, solution. What is our solution? 1, negative 3. And which method was this? Substitution. Did we substitute a lot? Yes, that's what's called substitution. Will that be the easiest method to use for that setup? For this original one? What would be the easiest method? Elimination, because we can just eliminate the x's and just combine the y's. Okay? All right, let's go to number 2. Now, a lot of you probably already forgot again about number 2. This was what we covered right before the semester, remember? So let me walk you through this one. Here it goes. It says, sorry, and make some room. It says, write the equation of the line with slope 3 that passes through the point 2, negative 6 in slope-intercept form. What did I say as soon as you heard this? To write what? Y equals mx plus b. To write our equation, we need 2 pieces of information. We need a slope, and we need a y-intercept. Do we have a slope? Yes. What is our slope? 3. So instead of m, I'm going to write underneath 3. Do we have a y-intercept? Do they say the y-intercept is this? No. If they don't give us the y-intercept, we need to find b. In order to find b, we need an x value and a y value. Do they give us that? Yes. X, y. So my x value is 2, and my y value is negative 6. Equals, bring down the plus b. Does this look familiar? Yeah, it's coming back, right? So let's see. We're left with negative 6 equals, what is 3 times 2? 6 plus b. Let's solve for b. What do I do? To leave b by itself? Subtract 6, subtract 6. We're left with negative 12 equals b. And this is canceled. So do we have a slope now? Do we have a y-intercept now? Yes, now we can write our equation. So I write y equals, instead of m, I'm going to write 3x plus, and instead of b, what do I write? Negative 12. Or it could be written as y equals 3x minus 12. That's it? Is it coming back a little bit? Yes? Yeah. All right, set that aside. Get a blank sheet of paper out. Title it Applying Systems Part 2. Part 2. Today we're going to get into funner ones. Yay! Someone is like, okay. You don't need a Ferri model. By now you should know what system of linear equations are. Let me skip. No, this is Fridays, part A. Because some people were absent. Who was there? Anyone absent in this class? Okay, so I need you at lunch here. You come part A. All right, it says our objective. I can solve real-world problems using system of linear equations. Read together. 1, 2, 3. So you're going to title your notes Applying Systems Part 2. Today we're going to be looking at another form of word problems, and I know you guys are going to love these. I just got used to the other ones. I know, right? And now we have to move on to funner things. So our concept for today is what? System of linear equations. So that we don't have to fill out a Frere model. Tell your neighbor the definition for systems of linear equations. Tell your neighbor the name or definition of system of linear equations. Let's see, Megan. Definition for system of linear equations. A set of two or more linear equations that have the same variable. Let's see if she got it. Bam, let's go. I know, right? And in your own words, it should have been two or more linear equations with the same variable. Something like that, yes? All right, examples on examples, a couple of hashtags, okay? Once again, we don't need a Frere model. And just to recap on the acronym that we've been using to solve word problems, here it goes. Problem solving strategy. Step 1, circle important numbers. Step 2, underline the question. Step 3, box important terms or ideas. Step 4, exclude unnecessary information. Step 5, draw pictures, diagrams, tables, labels, etc. Okay? So, last week we covered this kind of problem. It says Reagan has $7.75 to buy 12 sheets of felt and cardstock for her scrapbook, and then they give you costs. And we said this one was called an item and cost type of problem. Is that correct? Then I gave you a different one. I said Noah spent $14.85 to buy 13 flowers and so on and so forth. And we also said and agreed that this was a item and cost type of problem, right? From there, we moved on to a rate problem. Remember these? You guys love these, right? With a tailwind, an airplane makes a 900-mile trip at 2¼ hours. On the return trip, the plane flies against the wind to make the trip in 3 hours. What is the plane speed? What is the wind speed? Right. Once you get used to these, these should be a piece of cake. So let's do one of these together. You don't have to copy problem number 4, but we are going to set up the table together, okay? So here goes. Problem number 4. Don't copy this, just write example 4, and then we're going to start writing when we start making the table together. But let me cube this so that we can have the information for the problem. I'm going to write cubed. And I'm going to start with blue. I'm going to circle important numbers. Well, it's a 600-mile trip. Okay. And it took 1½ hours. And then it says here return trip in 2½ hours. All right. I'm going to underline the question so I remember to answer at the end, or questions. What is the plane speed and what is the wind speed? So we need to answer two things, plane and wind. Let me box important information. What did we say was important? The tailwind. Tailwind. Words. And we're not in language arts, huh? How about against the wind? Against the wind. Yes, that's also important. All right. Exclude any other information. Now we're going to draw a table together. How many lines down, everyone? 3. 1, 2, and 3. And we said that this is a rate problem. A rate problem. And it says it here in the actual, in the problem that says speed, which is also considered rate. So what is the formula that we used for the rate? Yes. Yes, say the formula. Rate times time equals distance. And by now, you should know that formula, or else you're going to get these wrong from the very beginning. Once again, these are worth 5 points each. Okay? So what is the first piece of information that they give us? Tailwind. I'm going to do that in red for the first row. Tailwind. So, let's talk about the rate. We said that when we are running the mile and we have the wind at our back, also known as a tailwind because it's at our tail, does that increase our speed? Yes, it helps us with moving us, projecting us forward. So, hold on. So, here the rate, the plane speed is what? Increased by the wind speed. That's where you write P plus W. Yes?
On the other one, like the place that had 4,000, they had like still current, and then it had
boat. Yeah, different variables. Yeah, just the variables change. Did you ever hear that? Jordan saying that on the play sheet that I gave you guys one on an airplane, but another one about a boat and the water. So therefore, what would change in regards to those variables? Instead of P, what do we write? S for sailboat, or B for boat, and W for water. You can keep it at W or C for current. It's up to you. How much was the first trip? It was 1.5 hours, 1.5, which is here. And what was the distance? 600. All right, I'm going to switch to blue for the second part, which is what? Against the wind. Against wind. Fill that in by yourself. Fiona, you all right? Yeah. All right. So what do I write right here? It's Ayana. P minus W. 2.5. 600. Hands, have you got that? That is correct. Now I want you to write the system. Let's see if you remember how to write the system given that information. Go. Okay, check with the neighbor, see what they got. See if they have something similar to yours. Okay, so Cloudy, tell me what to write. P plus W plus close times. And how do we indicate the times? Or parenthesis. 1.5 equals 600. And if you got it to right there, okay, good. And the other one is P minus W times 2.5 equals 600. All right. So far, if you got these two pieces, that's two points already. So now let's start solving, but we can't because they look a little bit funky because they have the 1.5 and the 2.5. So you know what we can do with the 1.5 here? Everyone?
You gotta divide.
Divide by 1.5 because the 1.5 is multiplying, so to get rid of it, we divide by 1.5 both sides. we're left with P plus W equals 400. Divide by 2.5, divide by 2.5. Therefore, P minus W equals then do the division. 600 divided by 2.5. I'll wait for you. No, it's not 350. $240. That is correct. All right. So, what do I do from there? Clarissa. Well, you what? Eliminate the W. And what do I write? Two P equals 640. Everybody with us so far? Yes? And then? Divide 2 to both sides. So the plane speed is 320 what? Miles per hour. All right. Now we need to figure out the wind speed. Which one do you guys want to use, the top one or the bottom one? Okay, the top one. All right, so this is P plus W equals 400. Okay, so we substitute instead of P, we substitute 320. Bring down the plus W equals 400 minus 320 minus 320. Therefore, the wind speed is 80 miles per hour. All right, let's write a statement. Who's got a statement for me? Jordan.
The plane speed is 320 miles per hour.
The plane speed is 320 miles per hour, comma.
And the wind speed is 80 miles per hour.
And the wind speed, the plane's speed, wind speed is 80 miles per hour. 10 Q. Yes. Oh, yeah. Pretty simple, yes? Did it come back? Yeah? All right. So, now that we're done with the simple ones, yay, move on to the funner ones. Copy this one, please. Example 6. Example 6. Copy this, please. And yes, you do need to copy the entire problem. It says, example 6. A chemist mixes a 20% saline solution and a 40% saline solution to get 60 milliliters of a 25% saline solution. How many milliliters of each saline solution should the chemist use in the mixture? Jordan asked if we need to copy that. Oh my goodness. Yes, I said copy the problem. It's imperative you copy it. Then get another paper. Oh my goodness. Yes, people, if you don't have any room, get another paper. Believe it or not. Be nice. Everybody done? Okay, come on, tomatoes. How about now? Okay. Focus, please. Focus. It's imperative that you stay on task.
Oh, you have to. So it's important.
Also, FYI, BTW, I was talking to some of our other teachers, and I noticed that there were a lot of students that were going to be gone on Saturday, so I went ahead and moved Saturday Academy to the following Saturday. Not this Saturday, the following. So make sure you tell your parents. I think there was going to be like close to 65 to 70 students out because of some were going to the robotics Mesa competition, and some others were going to be helping at the basketball tournament and so on and so forth. So this Saturday. Yeah, so we're moving from this Saturday. There is no Saturday Academy this Saturday. We're moving into the next one, which is the 20th. The 27th, I'm sorry. Yeah. Yes, so January. All right, here we go. Everybody ready? All right, writing utensils down. Look up to the screen. You guys ready? All right, here we go. All right. One thing that you should notice, and on this one they're not talking about money anymore, and they're not talking about rates. Stay focused, please, because this is one of those that I start losing people on these. However, what is the one thing that you see that is predominant throughout the problem? Percent. What else? What word keeps coming up? Well, yeah, that's part of the mixture. But what is it? Mix, mixture, or mixes. So this is what we call a mixture problem, or we also call it a percent and decimal problem. And I'll show you how that looks. All right. So with that said, I'm going to go ahead and break this down using cubes. So I'm going to start with blue. Let's do this one together. Ready? So circle important numbers. Important numbers is 20% saving solution, 40% saving solution, and 60 millimeters of 25% saline solution. Underline the question. What is the question? How many milliliters of each saline solution should the chemist use in the mixture? And double underline milliliters. All right, box important information. Now this is key right here. The chemist mixes. Whenever you see where it says mixes, that means that the mixtures are coming up. So mixes what? What does she mix? 20% and 40%. So that means this one is number 1 and this one is number 2. So how many different mixtures? 2. Okay. Also, what's important? The words to get. What does that mean? To get. Mixes this and that to get. What does that translate to? Equal. To get means equal. All right? Exclude any other information. Now let's draw a table. Let's draw a table together. Here we go. The table is very similar to what we do with the others. So 3 lines down. 1, 2, 3, and 2 across. The first column is going to be our first mix. The second column is our second mix. And the last column is our total mix. Yes, that's why it's mixture problem, because it's always mixing. Yeah. So that we stay focused on the problem. Which one of these is our first mixture? Is it 20%, 40%, or 25? 20. So I write right here 20%. So I keep it organized. How about our second mixture? 40%. And our total is 25%. Okay. So this is very similar to one that we started with the word problems. Instead of saying item and cost, this one would be item and percent. So I'm going to label the first row item. And what item are they talking about? Let's see. Do we see anything up there that we can write? Saline solution. So I'm going to write saline solution. And right next to it, you're going to write ML, which stands for milliliters. Question. Let's look at the first mixture. The chemist mixes 20% saline solution. Do they tell us how many milliliters for the first one? No. So what can we label this first one? Okay, once again. Do they tell us the milliliters? No. So what can we label this? X. Do they tell us the milliliters for the second? So we label that Y. And it says to get, which means equals. So they tell us the milliliters. 60. But 60 of what? Of 25%. So we'll get to the percentage in a little bit. So 60. There it is. So far so good? All right. Next row, we're going to label it percent. But instead of writing it in percent, since we need to translate that into milliliters, we're going to write in decimal. So, question. How much is 20% in decimal? 0.20. And do we know how many milliliters did we get? No, so it's 20x. What is the next fixture? 0.40y. And what is the total percent? 0.25, but do we know the milliliters that it came from? Yes, 60. So on this one, we do need to multiply. So what is 60 times 0.25? Do the computation and give me the number, please. 60 times 0.25. 15, I heard. That is correct. Okay. Do you guys see the system now? Write it out. Let's see, I'll give you a head start. Write out your system. See if you see it. Okay. Tiger, give me your system. Karina? Hold on. What is our first equation? x plus y equals 60. And then the second, 0.20x plus 0.40y equals 15. Hands if you got that. That is correct. So far we have 2 points. One for our table organization and another point for our system. So does this look familiar now? Yes. Now we can decide, we can use the elimination method and decide which variable to eliminate. So question, which one do you want to eliminate? Emerald. X. She wants to eliminate x, so we need to multiply the first equation times what, everyone? Negative 0.20. So distribute, and we end up with negative 0.20x, negative 0.20y equals negative 12. And now you should be able to eliminate. I'm going to switch to red. Which one eliminates? The x. What is 20 minus 20? Cancels. What is 0.40 minus 0.20? 0.20y equals 15 minus 12, 3. So then at the end we would divide by 20, divide by 20. We end up with y equals 3 divided by 0.20. Let's see, 3 divided by 0.20. Move the decimal twice, which means we add 2 zeros. So 20 fits in here once. Add a 0 4 times. So this is 14 what? Milliliters. That is correct. So we're done with the first part, which is this one. Y is 14. So which one do we need to solve for? Yeah. 15? Let's see, 4 times 2, that's 8. Yeah, it's 15, right? Who said 14? Who said 14? Megan.
Oh my goodness.
15. Who said detention? John? John, detention. All right, 15. So now that we figured out y, which equation shall we use to figure out x? The original one, right? This one. So we write x plus y equals 60, but instead of y we substitute 15. So x plus 15 equals 60, minus 15 minus 15. X equals 45 mLs, and that goes right here. This is 45. And why do we need to, check this out, for this one we do need to write it in here so that when we write our sentence we don't get mixed up. Get it mixed up? So it says, how many milliliters of each saline solution should the chemist use in the mixture? So let's start. The chemist mixes 45 milliliters of how much percent? Of 20% saline solution. Did everybody know where I got this from? Okay, comma, and what else do I write? 15 milliliters, mLs of what? 40% saline solution. 10Q. And once again, where did we get those numbers? 45 of 20 and 4. This was 15. Sorry. 15. 15 of 40. 15 of 40. So what do you notice on this one? The only thing that you need to worry about is the setup. Is that correct? Other than that, everything else is something that we've been practicing. Okay? So I'm going to move on to the next one. You're going to set up the table for the next one. You don't have to copy the whole problem. Is that okay? So you guys want to copy the problem? You all right? Okay. Example number 7. It says, I'm going to cube it for you, and then you get the information from there. Cube. Suppose a pharmacist wants to get 30 grams of an ointment that is 10% zinc oxide by mixing an ointment that is 9% zinc oxide with an ointment that is 15% zinc oxide. How many grams of each ointment should the pharmacist mix together? So I'm going to start with blue. I'm going to circle important numbers. 30 grams of an ointment that is 10% zinc oxide. Okay. And then 9% zinc oxide and 15% zinc oxide. Okay. Underline the question. How many grams of each ointment should the pharmacist mix together? Box important information. Let's see. A pharmacist wants to get. What does that mean? Tell your neighbor, please. What does wants to get mean? What symbol would that be? That is correct. This is our equal. So who notices on this one? Look up really quick before you continue. Look up. Let me go to the previous one. We'll notice on this one that the equal was towards the end. And here, the equal is towards the beginning, so they can throw us off a little bit. So what does that tell you? That the 10% is not the first mixture. What's our first mixture? Let's see. By mixing, what do they mix? 9%, so this is our first mixture. And 15% is our second mixture. All right? So with that, exclude any other information and draw your table. I'll give you a head start. Make your table given that information. I know, right? They do a good job by giving you a percent at the beginning, but the percent is the actual total. Okay? Some of you seem tired and don't use the excuse, oh, because it's Monday. Because it's not Monday. But Tuesday is like Monday, all right.
Every day is Monday, and what's the Friday?
Answer if any more time. Okay, 1 minute. In the meantime, I'll get started. 1, 2, 3, 2 across. Should label this one first mix, second mix, and total. Yes? What is our first mix? You should have written 9%, then 15%, and then 10%. So here I wrote item, which is what? Zinc oxide. So what do we write here? X, Y, and how many? This one is not milliliters, it's what? GM, which is grams. How many grams? 30. The second one is percent, but in decimal. Okay. 9% is 0.09x. 15% is 0.15x. And this one is 0.10%. Oh, this is Y, sorry. Yeah, Y. This is 0.10 times 30. What is 0.10 times 30 is 3. And do you know how to write your system? And do you know how to resolve? Yes? All right, our home plate for tonight is on pages 326 and 327. There's no tutor. Have a meeting. Hold on. Also, don't do number 24. Okay, because we still haven't covered that one. Okay? Once again, there is no Saturday Academy this Saturday. It's still the following. Have a good one, guys. See you guys tomorrow. Bye.